if we're talking about the accuracy, so here you can see that, okay, like let's go over here and understand this. So here see actual, how many actual values are from class 0, you know, 4 values are there. How many actual y values are from class 1? 6 values are there. So out of, 4 class 0 values, model just predicted the 3 class 0 values correctly and one is incorrect prediction is there, right? Out of 6 1 values, okay, model predicted the 6, all 6 values which are correctly predicted by the model, right? So there is only one incorrect prediction is there. So here how many correct predictions are there? Total 9 correct prediction in the, in the confusion matrix. If you sum the diagonal value, so you will see that 3 plus 6 equal to 9. So okay, these diagonal values which are nothing but the correct prediction, right? These diagonal values are nothing but the correct prediction, right? And if we're talking about the non-diagonal values, so if you sum this non-diagonal values, so you will find that the one, non-diagonal value is there. So here accuracy equal to, okay, how many correct predictions are there? Total 9 correct predictions are there because 3 plus 6 equal to 9, right? Divided by how many observations are there? Total observation, total 10 observations are there. So your accuracy will be 0.9, right? Your accuracy will be 0.9, isn't it? Which means that, okay, your model 90% of time your model is correct, and only 10% of the time your model, showing you the incorrect predictions. Okay, now what about precision? What about precision? So in simple words, okay, precision is nothing but the, the accuracy of your positive predictions. If you are talking about the class 1, okay, if you are talking about the class 1 is the positive, okay. If you are talking about the, the class 0, so you can say that the accuracy of your class 0, the prediction of class 0, right? So precision in short is nothing but the accuracy of your class, either class 0 and class 1. So you will find that, okay, for this data, okay, precision, which means the accuracy for class 0 is 100%. Understood? What about next? Okay, here for class 1, there is 86% accuracy. Model is able to predict class 1 values 86% of time. Okay, so that is the accuracy of the class 1. Okay, what about the recall? What about the recall? Now basically recall just measures the completeness of your predictions. Okay, recall just measures the completeness of your predictions, which means that here you can see that we got the 0.75 as a recall, which means that the 75%, okay, your class 0 is, model is able to, find out the, 75% of that, or the completeness of your class 0. Okay, what about class 1? 100% of the time. Okay, so 100% of the time model is able to, find out the positive predictions. Precision basically, you know measures the accuracy of your either positive predictions or negative predictions. So I can write the accuracy of your class prediction, right? Class predictions. What about next? The precision. Basically precision, okay, measures the completeness completeness of your class prediction. So precision, we can simply say the accuracy of your class predictions. Okay, either class means 0 and 1 class, right? Okay, what about recall? Recall measure the completeness of class predictions. Okay, true positive. Okay, that's great to see. Okay, true positive plus false positive, right? So here you can see, okay, my true positive is how much? 6, right? How much? 6 is there. So let's go ahead with the calculation. Okay, so simply what I can do is I can write the formulas first and then we'll do the calculation itself in the Python. So we can cross check, okay, with the formulas and these values, right? So true positive plus false negative is there, right? So these are the two formulas which are there for the precision and recall. Okay, you can use it for your reference. Okay. Mm, I can simply use like this, enter it. Okay, now let's go ahead with the precision first. Okay, so what is our true positive? Okay, what is our true positive? So here you can see that the 6 value is there. Okay, so 6 divided by, okay, then we have the true positive plus false positive. Okay, we have the true positive plus false positive. So here you can see 6 divided by 6 plus 1, and let's go and enter it, and let's round this, round, okay, up to 2 decimal points, 0.86. Okay, so here you can see that the precision for class 1. Okay, if you wanted to find out the precision for class 0, so what is the formula now? Okay, as we know, this is the formula for class 1. Okay, this is the formula for your positive class. What about negative class? Now the precision value for this particular negative class is going to be the true negative divided by true negative plus false negative. Okay, now this these formulas which are for, okay, class 1, or you can see that the formulae are for class 1, or in short you can say that the your positive class, right? So that's why you will see that the true positive is there, true positive is there, true positive is there, true positive is there, right? Okay, if you wanted to find the the formulas for the class 0, right, the for formula for class 0, or in short your you know negative class. So here just add the true negative here. Okay, true negative, and this is also false negative, not the false positive. Okay, and here recall for class 0 is going to be the true negative divided by true positive plus false positive. Okay, so this is the formula. Okay, so you will have to you know understand these things as well. Okay, formula will be changing for class by class, right? So this is for class 0 and this is for class 1. So this is first the, I would say, the precision for your class 1, right, or class your positive class. That's why I mentioned the 1 here, remember. Okay, and you know, precision 1. So here you can see this thing. Okay, then what about your recall? Okay, let me do the same the precision recall in this particular cell as well, so you will understand. Okay, that's why what I can do is I can use the uh, no, I can simply add the one more cell over here, so you will understand. Okay, separately it's better. Okay, let's put recall. Okay, and here also just put the recall for class 1. Okay, now here, as we know, the formula for class 1, okay, and the formula for recall for class 1 or your positive class is going to be the true positive divided by true positive plus false negative. So which means, the true positive divided by again true positive plus false negative. So now here we got the formula like this: 6 divided by 6 plus 0. Okay, this is my recall formula. Okay, this is my recall formula, right? Now what about the formulas for class 0? So here these are the formulas for class 0. Let me create the new cell. Okay, these are the invalid syntax. I'll just make it markdown cell. Okay, now here you can see that, guys. Okay, the recall value for class 1 is 1. Okay, you will find that the recall value for class 1 is 1, this thing. Okay, correct. So here we just cross check that the record value is 1, and recall value basically measures the completeness of your class prediction, of your positive predictions, right? That is the thing. Now let's go ahead and find out the precision and recall for your class 0. Okay, so you can simply copy this thing over here, right, and make it 0 only. Okay, make it 0 instead of 6. You can mention the true negative, which is nothing but the 3. Here you can see in the confusion matrix true negative is going to be the 3, right? Then what about next? Okay, the true negative, which means the 3 value is there. If the recall formula is wrong, then we will never get the correct value. You will see that we got the value for the class 1, which is 1.0, which is 100%. So here you can see that the for class 1 the value is 1. Okay, so how you can describe the recall formula is, class recall formula was wrong. Yes, that's why the name for the confusion matrix is the confusion matrix. So you know sometimes people will confuse in false positive and false negative, right? Okay, you will have to understand these all the things, then you will know what is recall, what is precision is. Okay, and this precision and recalls for are different for each class. So here you will find that the formula for the class 0 is different, right? So here let me show you, this is the false negative now. Okay, the false negative is going to be the the going to be the 0 here. So let me go ahead with, okay, false negative is going to be 0 over here. So you will find that the precision value, yeah, so here you will see that the for class 0 precision value will be 1. So here you can see that. Okay, let's go and run. So see, precision value for your class 0 is going to be 1, and that is correct. Okay, that is correct, right? This is a precision value for your class 0. Okay, what about recall value for class 0? Let us copy this thing. Okay, and go with the formula. Here you can see that the true negative is there. So for true negative, the value for true negative is 3, right? Okay, value for true negative is 3, and value for false positive is going to be 1. This is a false positive, right? So let us go ahead with the 1 value. Okay, So let us go and run. Okay, and here you can see the recall. Okay, this is not the class 1, this is the class 0. Okay, recall value for class 0 is going to be 0.75. Here you will see we created a classification report, we got the precision, recall, F1 score, support, accuracy, and all these things. And here you will see that, okay, we cross check with the formulas too. Okay, which means that our formulas are correct and our precision, recall values are also correct, right? Then what about F1 score? What about F1 score? As we discuss accuracy, precision, recall, support. What about F1 score? F1 score is nothing but the harmonic mean, okay, of precision and recall. Okay, harmonic mean of precision recall. So let's say sometimes, okay, if you confused about precision recall, so then simply, okay, don't get into this. Okay, because, okay, initially there are a lot of things you will have to understand, right? Am I right? Initially there are a lot of things you will have to understand. So what you can do is, initially you can simply understand the concept. Okay, only don't try to, understand the values of the precision and recall, because you will get confused in the formulas of that. Okay, in the initially only, after understanding all the concept what is confusion matrix is, okay, if you understood this 100% of the time, okay, if someone tell you what is confusion matrix is, so you are ready to explain what is confusion matrix is, then you can go ahead with the precision and recall. Okay, otherwise, okay, okay, like simply go with the F1 score. Now what is F1 score? So simply here F1 score will tell you that the, your model, how much your model is able to, make the, correct prediction about the class 0. So if let's say if your F1 score is 0.86, so which means that, okay, your model is strong enough. Because if your value of F1 score is tends to 1, then you can say your model is strong. If your F1 score value is tends to 0, so you can say that your model is not strong. So here in both the case for class 0 and class 1, you will see that the values are, quite good values. 0.86 is not a bad value, it's a very good value, it's greater than 0.85, right? Sometimes people are struggling to get the 0 more than 0.8 accuracy. Okay, I'm not talking about the accuracy, I'm talking about the F1 score. If you got the F1 score which is, greater than 0.85, so, believe me, your model is good, right? So in simple words you can say this thing only. Okay, if your F1 score here is high, okay, you're near about 1, so you can say yes, your model is good. Okay, and model is, good in the prediction of class 0. If you're talking about class 1, yes, F1 score is also good, 0.92. Okay, so you can say that model is also able to, making a, model is also strong to predict a class 1 values, right? So that's how you can understand the F1 score. So if you wanted to get the value for this, okay, you can simply know the formula of harmonic mean. So what is the formula of harmonic mean then? Okay, so if you know the formula of harmonic mean, so here you can see that, okay, the F1 score for your class 1. Okay, so here you can simply use the precision and recall for class 1 first. Okay, so 2 divided by, because there are only two values, right? Precision is, precision is 0.86. Okay, let us go with this 0.86 and check whether this formula is correct or not. Because, like the formula is like this. Okay, if you're talking about the harmonic mean, so you will find that the harmonic mean is looks like this. Okay, the F1 score okay, you will find that the 1 divided by, okay, 1 here your precision, okay, plus, okay, 1 divided by recall. So okay, and here you will find that the divided by 2. So after the solving this, you will find that the 2 divided by, okay, if you see that, okay, 1 divided by precision into 1 divided by recall. So you will find that again, if you solve this, okay, I'm gonna use this particular formula because this is simplest way to uh you know memorize the f1 score, because you will find that f1 score is nothing but the formula of harmonic mean. So harmonic mean you will write like this, okay, right, like this. Okay, if you solve this again, so you will find that here precision into this precision, and the recall, I would say, plus you know the recall divided by, here you will see that the precision and recall, right? Now you can simply use this. Okay, now you can put this in the numerator again, because this is a simple math step, so we don't have to worry about it. Okay, so p plus r. Okay, so this is the simplest way. Okay, again, okay, after solving this, okay, after basically why I check this, because okay, I will use this formula. Okay, so like after Sahana gave me this particular formula, so that's why I checked it whether it is correct or not, and absolutely that is correct. Yeah, so let us go with this. Okay, 1, then divided by simply, okay, our precision, which is I guess 0.86 plus 1, right? And f1 score is going to be this much. Okay, let us round this up to 2 digits, and let's run this, and here you go, we got the f1 score as a 0.92. Okay, we got the f1 score as a 0.92. Okay, so that is the thing. Got it, guys? Okay, so now, okay, it's up to you. You can simply, again, you can use the same thing. You can find out the value for you know class 0. Okay, now you can simply use this value instead of 0.86, you can use the 0.75. Okay, and you can simply run this thing. Okay, and enter this, and here you will get the 0.86. So 0.86 and 0.92 are the same values, okay, which we got over here, 0.86 and 0.92. So here you will find that, okay, why I did all this thing, why I show you this thing by formula and all this thing, why we check this all the things, why there is a need. Because guys, in the first time, okay, when you are dealing with something, okay, you should have to understand each and everything. That's why I showed you this. Okay, now let us discuss about the decision tree. Okay, at that time, okay, I will never discuss this thing with you, because in the first, okay, we already discuss about this, right? In the first we already discuss about it. Okay, so let us talk about the decision tree. So in the decision tree is yet another algorithm of classification. Okay, we can use the decision tree for the classification algorithm, as well as for doing the classification as well as for doing the regression. Okay, so this is somewhat similar, I can say, but the approach is different. Okay, like in the logistic regression we are going to use the logit function, but here we are going to use the entropy. Okay, we are going to use the entropy. Okay, then we are going to use the information gain, then we are going to use the Gini index. Okay, these are the few terms. Okay, with the help of that we will be building the decision tree. So let's discuss, let's understand what decision tree is, then simply go ahead with our coding part. Okay, so guys, okay, in the decision tree here you will see that, let's say we have the one problem. Okay, let's say we have the one problem is there. Okay, so, and what problem is that, does the person likes computer games or not? Okay, does the person likes computer game or not, right? So here you will find that, okay, here you will find that you have the data of your, you know, other members you took the data from. Okay, you check with the, you know, multiple persons now. Okay, so you have the person's data like their age, their gender, their occupation, right? So what we are checking is that, okay, depending upon their different, you know, inputs, their different features like age, gender, okay, occupation, like that. So we are asking the questions. Okay, this is a, you know, question based model, I can say. Okay, let's say, okay, if we talking about, if age is, you know, less than 15. Okay, we got, how we got this value, age is less than 15, and then we you know, split my data. So basically we can say that, okay, just by implementing the entropy information gain is the, you know, one measure. With the help of that we can able to, you know, find that the root node. So this is my root node in simple words. Okay, this is my root node, right? And okay, from that, okay, we can say like this. Okay, we can split the data. So here if age is less than 15, so we can say that, okay, here, okay, here the term is -1. The term is -1. So this is going to be the prediction score for each leaf. Leaf is nothing but your outcome. Okay, leaf is nothing but the outcome, right? So here you will find that, okay, first we go with the age column. Okay, we check with, if age is less than 15, so we can simply say that yes. Okay, the, you know, negative score is there, which means that, you know, they are we can say that the like they don't like, you know, computer games, like that. Okay, if we're talking about the yes, okay, then we'll go and check the another feature, whether the gender, okay, is that person male or female. If yes, so yes, they likes computer games. If, you know, if the, you know, the person is not male, so which is in fact female, so we can simply say that, you know, they also like the, you know, computer game, but a little, okay, not that much, okay, as the males like, right? So this is how you approach with the decision tree. Okay, so let me show you another example, okay, in the whiteboard, so you will understand again the different one. Okay, now at this time, okay, my question is to, you know, depending upon the few criterias, okay, I just wanted to you know, decide whether you know, I'm gonna, you know, the accept the offer from the company or not. Okay, let's say, okay, I, you know, I did the interview of one of the company, okay, and, you know, they give me the offer letter, right? So, so in the first, what will I check? I will check, okay, the different things. Okay, first let me, okay, I'll check the salary. Okay, how much salary they are offering. Okay, if the salary is in my criteria, so I can accept the offer, or otherwise the rejecting the offer, right? If salary is in my range, okay, let's say whatever range, xyz range I want in as a salary, okay, in that range if the salary is there, so I'll accept the offer, otherwise I can reject the offer. Okay, then this is my first criteria. What will be my second criteria? Here you will see the second criteria. Let's say, okay, I just wanted to see, okay, the whether, okay, company is giving me, you know, work from home or work from office. Okay, work from, okay, home or let's say work from office. Okay, so I'll check this thing. Okay, if I'm comfortable with work from home situation, so if the company is giving me a work from home, in that case I'll accept the offer, otherwise I can simply reject it. Okay, now third situation, okay, is the company near to my home? Okay, if not, so are they providing any cab facility or not? I'll be checking this thing as well. Okay, if company is near to me, and let's say I just wanna, I don't wanna, go with the work from home, okay, or the remote location. Okay, so what I can check is, okay, if the work is like, let's say, work from office, so what I can do is I'll check, are they providing a cab facility? If yes, so I can simply accept it or reject it. So here you will see that the accept the offer, okay, or simply the reject. Okay, right? So this is how, okay, humans, okay, are just making the decisions. Okay, in the same way, okay, decision tree is also making the decisions, right? Decision tree is also making the decision. Understood, guys? And here, okay, these are the few terms. Okay, this is going to be the root node. Okay, these are just the nodes. Okay, this thing, these are just the nodes, you know I can say these are, okay, you will see these are just the leaf node, right? So these few criterias are there. Okay, we will have to understand these terms. Okay, what does this mean and what does this mean? Okay, so that is the thing. Okay, so that is the decision tree in short. Okay, so what we can do is we can now simply take a simple data, right, and implement the decision tree on it, right? And one more thing, guys, the data again is pre-processed. Okay, because if we go with the again the for each and every data set, if we go with the pre-processing steps, then it will be very time consuming process, right? And as you know, we have the some limited amount of time. So that's why let us go and use the pre-processed data and implement the decision tree algorithm, right? It's very, it's very cool algorithm. Okay, now again, as we know, guys, what are the different libraries we wanna import? Let's say we created the new notebook, so that's why we'll have to import the again the libraries. So that's why what we can do is we can use the same libraries over here. But now, okay, now we can simply you know change this linear model to our decision tree model. Okay, right? We just wanted to change this thing. Okay, so there are few things which are there. Okay, we can do this thing. Okay, we can simply go with the tree method is there, and in the tree method you will find that, okay, let me remove this and just use the you know tab, and in the tab you will find that, okay, there are multiple you know algorithms are there, like base decision tree is there, decision tree classifier is there, tree regression is there, then export graph is, this is the visualization of decision tree, right? Export text is there. Okay, you can export the decision trees of all the fundamentals, like how the decision tree you can create that kind of text, you can export it. Okay, then extra decision tree classifier is there, extra tree regressor is there. Okay, these are the few algorithms are there, means which means just the variety of algorithms, you can simply say. Okay, this is a classification problem because we are talking about the classification problem, right? So that's why I'm gonna use the decision tree classifier over here. So let's go and enter it. Okay, if you wanted to solve the regression problem, so you can use the decision tree regressor. Okay, these are the few things. Okay, now in the data set, I just wanted to as we are coming with the going forward with the multiple data set. So as we know, okay, each and every data set is different, so we will have to make few changes in our data set, right? We will have to make the few changes in our data set, isn't it? So at that time, okay, these are the few things we'll have to do. These are the compulsory one. Let's go and run this. Okay, and let's go and read the data. Okay, then at that time, okay, when we are dealing with that particular situation, let's say to split the data, we need again to import the sklearn dot model selection, import train test split method. So at that time we'll again use that particular code to import that particular method, right? So let us go ahead quickly and import the our data. Okay, so here I'm gonna use the read the user's data. Okay, as I shared the user data with you, so I know, okay, we will find the user data over here. Yeah, user data dot csv. Okay, and I hope you got the the user data file as well. You downloaded it from the drive, right? If not, try to download it. Okay, now this is my user data. Okay, let's go and run this and let's see the data now. Okay, this is my tf dot head. I just wanted to see the top 5 entries of my data, and here you can see the user id, gender is there, age is there, estimated salary is there, and purchase history is there. Okay, now what is my problem over here? I just wanted to create a classification model. Okay, okay, this is the first thing I just wanted to do. Now here you can see that in my data you will find that the user id is there. Okay, now user id is just the is just the the nominal scale data, just the label. Okay, that we wanna uh, you know just the unique label or the unique id, I can say, right? Primary key in sql, right? That is my user id, right? Then I don't want this because this is not helpful for my model building part. So what I can do is I can simply remove it, or I can simply drop this particular thing, right? So instead of dropping, what we can do is, okay, we can taking the few columns which we will be using for our further analysis, right? Then second column is gender. Okay, gender column is there again. Then we have the age, right? Okay, then we have the estimated salary column. So basically these three columns which are important for our analysis, right? These three columns which are important for our analysis. Then we have the purchased history. So basically depends upon my data of the customers. Okay, we will have to identify whether the person purchase my particular product or not. Okay, so this is my target. Okay, this is my target. So I have past data depending upon the age, depending upon the gender and their estimated salary. Okay, I will check whether the customers are preferring to purchase my product or not. Now our main goal is to what is my problem. Okay, I just wanted to build a model of classification. Why I wanted to build a model of classification? Because I just wanted to see whether customer is interested to purchase my product or not. That is my main problem. Okay, I just wanted to check whether the customers are interested to purchase my product or not. Okay, and on the basis of their estimated salary, age, gender, okay, I will check, okay, whether the customer is going to purchase my product or not. So I have the data of few customers, the past data, and the customers which didn't purchase my product as well. So I took the data of those customers as well, because they just visited to my uh, website, okay, and just I just took the survey, okay, from those customers, okay. So, and in the survey I got these many features: gender, age, estimated salary, as well, okay, as well as we got the lot of things, right? But here you will find that, okay, we took this much only, because just to show you how to implement the decision tree. That's the main aim of mine over here in this for this particular session. Now here, okay, in I'm gonna use the age and estimated salary as my independent features. Okay, age and estimated salary, because of the due to the time restrictions, okay, we'll have to go with this two salary, the columns, okay. Because here you will find that the gender column is the again the male and female column. I'll have to add the one hot encoding to change that again and do some pre-processing again. So because of time restriction, okay, we'll go ahead with only age and estimated salary, and we build the model which can predict the purchase history, right? Which can predict that person is able to purchase my item or product or not, right? So for that, I can simply split my data into as the my input data and my output data. So what is my input data? Okay, df dot ilock. As we know, we use this method in the previous sessions as well. Okay, all the rows I want, but in the in the X only, I want age and estimated salary. So I'll use the age and estimated salaries index number over here. Okay, so I'll add the index number like this, the 2, because here index number start with 0, then 1, and for age index number is 2, and for estimated salary index number is 3. So what I'll do is I'll add the index number as the 3, right? So I mentioned these 2 and 3 in the list. That's why, okay, I'm able to get the output, okay, as the age and estimated salary. Okay, if I'm using this like this, okay, 2 and 3, then you will get only 2 column, not the 3. But now understand, I will be using the 2 and 3 in the list, okay, in the list. Then we will be getting the values, okay. So I want the values now. So what I can do is dot values. Okay, I want the values only, not the name and all. Okay, second thing is that I wanted to extract the target from my data. Again, I'm gonna use the ilog method. Okay, I'll use the square brackets. I want the all the rows of my target column, and I want the my target column which is of the indexed 4, right? That's it. Dot values, I just want the values, nothing else. I don't want the column name and all, right? So these are my, this is my data. Yeah, now after this, after getting the data X and Y, okay, here what I can do is I just wanted to split that data into training and testing. Okay, and why I just wanted to split that data into the training and testing? Because I will build the model on the training data, and I will make the prediction on the test data. So, okay, which means that I I will be checking my model is comfortable with the new data or not, right? So, let us do that. Then you will understand this thing. sklearn, okay, dot model selection, okay, import train. Here you will find that the train test split. So many things are there, guys, huh? Okay, train test split. Now here you will find that I'll have to add the the data sets which I wanted to create from this. Okay, so how many data set I just wanted to create? I just wanted to create the data for the X train, right? I just wanted to create the data from X test, right? And remember guys, the order for this data set is very much important, huh? Okay, if you miss the order, you will get the wrong results. Okay, Y train and Y test. The order is very much important. Train test split, just add the X data, just add the Y data, and I just wanted to take the my training data as a 70% of my overall data. Okay, so that's why I'm gonna make the set the size for the test data is going to be the 30%. So 30%, which means 0.3, right? 0.3. And basically this is going to be the splitting, but in the form, okay, in a random way. Okay, as we know, we understood what is the simple random sampling is. So in the simple random sampling, which means we are taking a samples randomly from the data. So here we are doing the same thing. Okay, we are taking the samples. First we are taking the 70%, okay, random variables, random values from my original data, right? And we are taking the 30% of my data, which is totally taken by random in my test data. Okay, so 30% as my test data and 70% as my trained data, right? So, and last step is going to be the random state is there. Why? Because after doing this, I don't wanna see any changes in my accuracy. Okay, because let's say if you are working in a team, you want the the same accuracy each and every time. So then you can use the any constant value as the parameter parameter random state, and that particular constant value in your team, which means your all the teams are using a random state equal to 10. Okay, then all of you will get the same results. Okay, this is the thing. Now let's go and run this. Okay, now, okay, let me show you the the size for this train dot the size for this is going to be the 280. Okay, now what I can do is I can simply print the user data size dot shape. So I'll get the shape of my original data, then print of my extend data. Okay, then I can simply copy this thing. Okay, now here what I can do is I can simply copy the X train, then Y train, then X test, you know and then Y test. Okay, let me run this. Okay, user data is not defined. Okay, not user data, it's df. Okay, so yeah, so see, I'm doing this in front of you, so sometimes error will be might be there. So you will find that, okay, you will have to, okay, if you know how to read the error, then you will definitely you know able to read the error and you can solve that particular error, right? So here you go. Yeah, Y test. So here you can see that, guys. Okay, initially we got the data how much? 400 variables are 400 observations are there, and only 5 columns are there. Okay, out of which, okay, 4 columns are nothing but my input column and 1 column is my target column. Now here you can see that, okay, I took only 2 column as my independent data, X data, right? In my X data you will find that only two columns, and in my test data you will find that in my target data you will find that only 1 column. That's why you will see that only the rows, not the column. you know Understood? So this is the thing. Now we can do it. Okay, we can simply, here you can see that the second thing, okay, what we can do is, okay, now if you see the, let's say, okay, if you see the train, data, so you will see that the range, okay, range of your first column, okay, the age column, 49, 47, 50 is there, and the range of the estimated salary is very big. It's a 5-digit number, or sometimes might be 6-digit number you will get. Okay, so as compared to 2-digit number, okay, this is the 6-digit or 5-digit number. So when you are building the model, so at that time this column will dominate, right? Yes. So at the time of building the model, okay, this column will dominate. This column will have the highest weightage, right? And this column has the, lowest weightage. So I don't want this kind of scenario. I want these two columns will be on a, same weightage. So that's why what I can do is I can simply convert this data, okay, into a, I can do a data transformation. Okay, so I can transform simply the range of both the data. So that's why we have the few data transformation technique. So in the, that is nothing but a feature scaling. That is nothing but a feature, you know scaling, right? So here what we will be doing is feature scaling, okay, to, change the transform the range of both the data, right? And then, you know again for that, what we want, pre-processing pre-processing from sklearn dot pre-processing, import the one thing which is nothing but the standard scalar, right? We want the standard scalar, right? So this is nothing but a, okay, this is the, one method. With the help of that, you can transform this data into, yeah, and you can convert this into the same range, right? So that is the thing. So let's say, okay, so standard scalar you can do. uh, so I'll be creating this, okay. I'm gonna use this. Let me copy this quickly, okay. Okay, and after this I'm gonna use this or apply this on my train data, because you will find that we will be building the model on X train data, right? And then we will be implementing on the, you know the test data. So that's why we will have to transform this data. So this data is the, X data na? So X train as well as X train. Okay, so we will be transforming our both the data, the X train and the X test as well, right? So first let's go and transform the X train data, right? So we will be implementing stx dot fit underscore transform, right? Transform, right? So here simply add your train data, okay, and here copy this thing, okay, and put it over here, and simply change the data X test, right? And enter this. And now let me show you the data. Now, are you able to see we just change the data, we transform the data in the same range? Now the range for this is going to be the, the range of standard normal distribution minus 32 plus 3. You will see that the your 99.997, 6 times 9 means, around all the data, 100% of your data we just transform into the range minus 32 plus 3. Okay, so here you will see that the your initial data is this, and you just transform the data like this. So now, okay, my data is ready. So now let's go and build the model. Okay, so as we know, we created the model, we imported the model already. So my decision tree model is this, okay, decision tree. Now in short, let's go with the model name, okay. And as we know, the name of our model is going to be the decision tree classifier, right? Right, so this is my model's name, okay. Now what I can do is I can simply use this model to fit on my data, right? That we did in the logistic regression as well, right? So this is the thing. Okay, so here you can see that now we are using the extend, okay, data to make the model which can predict my y column. So we will be using this x and y data of the train for building the model first. So let's go and run this, right? So here you will see that I'm gonna run now. Okay, run this now. Here you can see that fit missing one argument, positional, why no, this is the method, this is not the attribute, right? Yeah, yeah, this is the method, this is not the attribute. Yeah, done with the the thing. Yeah, now okay, what we can do is after building the model, our aim is to go for the prediction one, right? So we can simply go for the prediction one. Here you can see that we are just making the predictions now. you know we are using the model dot pred, okay, model dot predict, and here we are simply implementing our x train data, and we will be getting our predicted values. So we can use that predicted values to build the confusion matrix, right? Okay, just we just going to build the confusion matrix, and in the confusion matrix we are using the y train, my target column, actual target column, and my predicted target column, y train predict, right? And let me go and see. So this is the first thing. Now what will be the second thing? Simply copy this, okay, and transform this at the classification report, okay, and make the use the print function, right? And let's run it. And here you can see that we got the output, and you know that how to rate the accuracy, precision, recall, F1 score, support, I told you already. Now this is for the train, okay? So you can do the same thing for the test as well, because we created the model, huh? So you can do the same thing for the test. So let me quickly show you, and then we will stop, guys. Now here let us use the test. Okay, we are going to make the prediction of the new day for the new data set. Okay, test is not, okay, test is my new data set. See, okay, we created the model, we built the model on the train data. You see that the train data we took, okay, we didn't touch the test data, right? We didn't touch the test data. Now we are using the test data to make the prediction of my, let's say, my model now using or handling the new data now, right? So that's why I'm gonna show you the results for this. Okay, so let me change this to train to test, and let me go and run this, then you will understand. Okay, here you can see. Okay, now initially my model is able to make the predictions, okay, 100% of the time correctly on the train data, but when it comes to new data, okay, new data that my model don't know about it, so at that time my model is able to get the accuracy only 85%. So you see the some kind of drop over here, some kind of drop over here. So you will find that for the new data set, for making the prediction about the new data set, you will find that some kind of less accuracy. Okay, so guys, that is it, how we can build the model and how we can check the model's credibility. Okay, credibility. So here you can see that the 85% accuracy is that for the for the prediction of new data set. Okay, so guys, that is it about the today's session. Thank you, guys. Thank you very much.